Hi everyone. So in this lecture we're going to talk about numbers and the different kinds of numbers that you'll encounter in this course. So the first type I want to talk about are real numbers. So what are real numbers? These are just numbers that can be represented with points on a real number line. So if you kind of think of a line, it's this continuous thing, and we can sort of represent these infinite number of points on here, and we just call those real numbers. So again, real numbers are numbers that can be represented with points on a real number line. All right. I will draw that below in a little bit, but just as a whole, the real numbers are much larger. They include rational numbers, which are fractions or decimals that terminate, like they stop, or maybe they have a repeat. Decimals that have repeats. So another way to think about real numbers is you can kind of think of them as numbers that have a decimal representation, and that decimal representation may be finite, or it actually could also be infinite. The ones that would have the finite representations, those would be rationals, because we can convert these into fractions. Okay, but really, most of the time you'll probably think of rationals as a ratio of two integers. Okay, so well, the set of integers looks like this, right? 0, 1, 2, and so on, and then also the negative integers, -1, -2, -3, and so on. And from those, the smaller collection would be the whole numbers, and that's just going to be 0, 1, 2, 3, and so on. And then if you take out 0 from this, this is sort of what we call the natural numbers, or your counting numbers. Okay, and we have some notation that we can use to represent these things. Maybe you've seen some of these things before. So like rational numbers, for example, you can represent that set of rational numbers with this fancy Q here, and integers you use a Z, and natural numbers, or the counting numbers, usually that's an N. Okay, some books, and you might actually see that they call these numbers the natural numbers. It's not really that big of a deal. I'm just kind of showing you how the real numbers can be partitioned into these sort of two families, where you have rational, nice ones, where they're ratios of integers, or you can also have irrationals. Okay, and when you see the picture of this, you'll see it's a little bit more clear, but the irrationals are the ones that you can't represent in this sort of nice way. They'll have either what you'll have is you'll have an infinite decimal representation where there's no repeats, right? This notation up here for the rational means 0.0121212. So that 1, 2 gets repeated forever. Okay, but that can actually be converted into a fraction. So an irrational, you'll have really no pattern there. It'll it'll be this infinite representation, and it won't fall under these two categories. Okay, so another one that you might be familiar with is pi, or things like square root of 3 or square root of 2. Those are irrationals. Square root of 4 isn't, because that's just 2. But yeah. Okay, so again, and real numbers, there is a notation for that as well. That's set. You can use this fancy R. Irrationals, we really don't have a notation for that. You can kind of think of it as like take all the reals and remove the rationals from it. Okay, so another definition. So a coordinate, so what would this be? So a coordinate is just a number associated with a point on the real number line. Okay, so now here is an example of a real number line, right? And we can designate where 0 is at some point. Just it goes infinite in both directions, but at some point we can designate where 0 is. Okay, and once we've designated zeros, then we sort of have an idea of where the positive numbers are. Positive real numbers would be to the right of the 0, and negative numbers are the ones to the left over here, right? They're the ones that are less than 0. So positive numbers, well, the integers are going to be these ones that are equally spaced out, right? So you'll have 1 and 2 and 3 and 4 and so on, right? We're not going to go forever here. And the negatives, you'd have like -1, -2, -3, and so on. Okay, but the real numbers make up this whole continuous line. There, any point on this line is a real number. So the integers are real numbers, right? They're this sub-collection up here that we're talking about. Real numbers making up both rational and irrationals, but the integers fall under this category of rationals because they are fractions. You could just take them and divide them by 1, and that would be a 1 representation of them. But there are other real numbers on here, right? So for example, pi would be right here, approximately 3.14159, and so on, right? Root 2 would be right around here, right? So root 2 would be right around there, and so on. So, and you could, you could have a half here, right? Just to give you a fraction or a rational. Okay, and yeah. So continuing on, let's try to solve an example together. So once you have this real number line, it's usually good to designate like where is 0 on this number line, just so you have kind of a relative place to compare all the numbers. And let's locate and label the points on the real number line associated with these numbers here. Okay, so -3.5, that's the same as -3.5. So what we could do is let's just start to label our negative integers. Okay, and -3.5 would be right here. So -3.5. Okay, this representation right here, -1.25, so we'd go -1 and 1/4 of the way between -1 and here. So this would give us -1.25. So -1 and 1/4 or a quarter. Oh, sorry. The pen sometimes makes the 9s look like 4s. Okay, or 4s look like 9s. And 1/2. So now let's go into the positive direction, right? Negatives and positives, you're going to immediately see them as real numbers because they'll have either a negative sign or not, right? So this negative sign means it's a negative number. This 1/2 has no negative, so this is going to be in the positive direction. So let's label some of the positives. Positive integers, I mean. Okay, and then a half will be right here, just like our example up above. So half or 0.5, right? Another way to think about that is you're taking the distance between 0 and 1 and dividing it in half, right, into 2, right? So that's kind of how you can connect up the geometry with the arithmetic there. And then 3/4, okay, so 3/4 of the way between 0 and 1 would be right here, right? So 3/4 or 3/4, and 2.5. So here's 2, and 0.5 will be 2.5, right? So that'll be right here.